The rational zeros theorem states that if p divided by q is a rational number written in lowest terms, and if p divided by q is a zero of the function f, a polynomial function with integer coefficients, then p is a factor of the constant term and q is a factor of the leading coefficient. The rational zeros theorem provides a method for us to find all possible rational zeros. So again, this is all possible rational zeros of a function with integer coefficients. So let's look at an example of using the rational zero theorem to work a problem. In this example, for the given polynomial function, we're asked to list all possible rational zeros, find all rational zeros and then factor completely into linear factors. So the first thing we're asked to find is the possible rational zeros. So what we need to consider is the factors of p. This would represent the p value, which is the constant, and then the factors of q. Q is the leading coefficient, so if our polynomial is written from highest to lowest power, there's understood 1 here, and this is our q value. So to find the possible rational zeros like we're asked to do in part A, we'll take the factors of p divided by the factors of q. So x equals the factors of p divided by the factors of q. So the factors of p would be numbers like 1 and 35. That multiplies to give us 35. But negative 1 and negative 35 also multiply to give us 35. So that's why we would say plus or minus 1 plus or minus 35. Similarly, we would say that positive and negative 5 and positive and negative 7 would be factors of 35. So those are all the factors of 35. If we consider the factors of 1, 1 times 1 is 1, and negative 1 times negative 1 is 1. So these are our list of possibilities, but they're not broken down into numbers that we can easily choose from. We want to take these values and consider positive negative 1 divided by positive negative 1. That gives us the option of plus or minus 1. So each value in the numerator divided by each value in the denominator. So positive or negative 35 divided by positive or negative 1 would give us plus or minus 35. Same idea for 5 and 7. Divide each of them by 1. So this would be our list of possibilities. Now, in part B, we are asked to find all rational zeros. So we need to determine the ones that actually work. So for part B, we're going to take our function f of x that was given equals x cubed minus 3x squared minus 33x plus 35. We're going to consider the list of possible rational zeros, and we're going to test them with synthetic division. What we learned prior to now is that if we do synthetic division and we get a remainder of 0, then we know that we have a factor of the polynomial. And part C in this problem has asked us to factor completely into linear factors. So what we'll do is we'll choose one of these possibilities, test it out, and see if it gives us a 0. For instance, we could choose the number in the list negative 1. When we test negative 1, we get 1, negative 3, negative 33, and 35. In synthetic division, the first step is to bring down the first number, so we bring down the 1. Multiply to get negative 1. This will become addition, so we add and keep the sign. We get negative 4, positive 4, negative 29, multiply to get 29, and we end up with 64. So our remainder in this case is 64. So that tells us that we do not have a factor using the number negative 1 is not a 0, x plus 1 is not a factor. So what we'll want to look at now is to choose another number from the list. So let's say we chose the number 7. We would do synthetic division again using the number 7. So we would have the 1, -3, -33, 35. Bring down the 1, multiply to get 7. Subtract to get 4, multiply to get 28. Subtract because our signs are different and get -5. Multiply to get -35. This time we get a remainder of 0, which tells us that x equals 7 is a 0, but it also tells us that x minus 7 is a factor. So if we'll continue on to part C, we know we're looking for the factors. We just found here that x minus 7 is a factor. To finish answering part B, we'll move on to part C. So part B asks for us to find the actual zeros of the function. X minus 7 is a factor. X equals 7 is a 0. So for our answer to state the zeros, we can go ahead and start to fill in the blank. 7 is one of those zeros. Part C told us to factor into linear factors. So if we take this work that we've done here where we found a 0, we can now say, like we stated, x minus 7 is a factor, so we have f of x is equal to, factor out x minus 7, and then we're left with these three numbers here will convert over to a polynomial. So our highest power was cubed. We bumped down to squared to write our answer for the polynomial that we have left. So x squared plus 4x minus 5. Again, those values came from where we did synthetic division, and we found these numbers from our synthetic division with a remainder of 0. We're now able to factor this completely. So f of x equals x minus 7, and then factor x plus 5, x minus 1. So in trying to find the zeros, we were able to continue on and factor it completely and answer part C. Once we know our factors, we can then find our zeros. If x minus 7 is a factor, then positive 7 is a 0. If x plus 5 is a factor, then what we'll find is that negative 5 is a 0. And if x minus 1 is a factor, then positive 1 is a 0. Another way to work through and figure these out from our factored form to determine the zeros is we could take each of these factors, set them equal to 0, and solve. Because if they're a 0 of the function, then we can take each of these, set them equal to 0. We would get x is 7. That was one of the zeros we found. X plus 5 equals 0. We would get x equals negative 5. That was one of the zeros that we found. And then we could say x minus 1 equals 0. So x equals 1. And that was the last 0 that we found. This question also asks for us to list all possible rational zeros, find all rational zeros, and then factor completely into linear factors. So to find the list of all possible rational zeros from part A, we'll look at the factors of P divided by the factors of Q. The factors of P are going to be plus or minus 1, plus or minus 5, plus or minus 7, plus or minus 35, divided by the factors of Q, which are plus or minus 1. Now we want to separate these out as plus or minus 1 over 1, 5 over 1, 7 over 1, and 35 over 1. So this is our list of possible rational zeros for this function that's given. Now we want to find the ones that actually work. So if we find one rational zero, then we can answer part C by factoring completely, and that'll allow us to find the other two rational zeros. So let's test out and see if we can find one that works. Let's say we test the number -1. So off to the side, using our polynomial, we'll take the 1, 11, 23, and -35. Bring down the 1, multiply to get -1. Subtract to get 10, multiply to get -10. Subtract to get 13, multiply to get -13, and then you'll add these to get -48. So our remainder here was not 0, so this is not considered a 0 of the function. So what we'll do now is we'll consider another one. Let's try +1. Okay, so 1, 11, 23, -35. Bring down the 1, multiply to get 1, add to get 12, multiply to get 12, add to get 35, multiply to get 35, and that subtracts out to give you the 0 that you were looking for. So what this means is that in answering the question for what are the zeros of this function, we found one of them. Since the remainder was 0, one of our zeros is a 1. Now, since our highest power in the given function was 3, we're expecting to possibly get 3 zeros for this function. So let's move on to part C in order to finish the problem. If we were looking at this function, f of x equals x cubed plus 11x squared plus 23x minus 35, and we were asked to factor completely into linear factors, then we would take this and we would consider that f of x is equal to, one of our factors is x minus 1, since 1 was a 0, x minus 1 is a factor, and then based on synthetic division where we found our 0, we'll use 1, 12, and 35 to write our polynomial that we need to factor further. So 1x squared, because we go down 1 power from the highest power in the function we did synthetic division with, plus 12x plus 35. Again, these coefficients here are coming from these numbers here. Now we will factor our polynomial completely to answer part C. So x minus 1 was the first factor that we found. Then we have x plus 7 times x plus 5 when we factor that polynomial. So this answers the question for part C. Factor it completely into linear factors, and that's what we've done. In looking at our answers, we can see that our other factors, x plus 7 and x plus 5, will give us zeros of -7 and -5. Again, you could go through to find those zeros by setting each of these factors equal to 0. X minus 1 equals 0, so when you solve it, x is 1. There's one of our zeros. Then we would say x plus 7 equals 0, so x is equal to -7. That would give us this factor. And then the last one, x plus 5 equals 0, so x equals -5. That would give us our third 0. So that answered part B that asked for us to state all the rational zeros. And actually, it asked us to state all the zeros of the function.